Okay, in this discussion, I'm going to go over the basics of building science and the factors that impact indoor air temperature in a building. So the primary goal of making a building more efficient is to control the flow of heat, air, and moisture in a building. And we'll go over all of that throughout this semester. In terms of temperature, though, the main goal is really to maximize heat retained during the winter and minimize heat gain during the summer. And overall heat loss and gain through the building shell, through and I would say around the building shell, through air leakage, are the largest demands on buildings. And I want to highlight here that really it's when we're controlling temperature, I want you to remember it's really all about heat. It's you know it, we are trying to prevent heat loss when we want to keep the building warm, and we are trying to prevent heat gain when we're trying to keep the building cool, like in the summer. It's easy to think like, oh yeah, we're sort of manipulating heat, and then we're manipulating cold air, but that's kind of only partially true. I mean, really, what we're like cold air is a lack of heat. Okay, and so when we quote unquote make cold air, what we're doing is removing heat from warm air. So it's really all about heat movement and controlling heat movement. And we'll go over some examples of that here in a minute. But you want to jot that down. Building science, again, this is a term just to jot down. This is used all the time in the energy efficiency field. It's just the study of how a building functions. It includes all aspects of building energy use, HVAC, the envelope, which is like the outside of the building with the insulation and all that, the building structure, moisture and heat movement, lighting and appliances, but it also includes occupant behavior. So an important part of building science is making sure that people are operating the building properly, and that can actually be a really big factor. So building science is just an overarching term for basically just studying how a building works. Okay, so every aspect of a building, all the systems in a building. So really, this course, if you're listening to this in building service systems, is a building science course because it concerns building systems. Okay, so in terms of the internal temperature of a building, again, we're really dealing with heat losses and heat gains. And so you want to think about the different sources of heat gain and losses in a house. So again, in a building, and heat gains can be either beneficial or non-beneficial. In the summer, obviously, we don't want heat gains. In the winter, we actually want heat gains. So if we can take advantage of some of these, it sort of depends on the season, the time of year, and the conditions of the building at any given time. But the point here is to start thinking about where heat comes from and where heat moves to, and how it does that in a building. And we'll look at that in more detail in labs and other parts of the course. So I want you to think about how heat can be gained in a building. Go ahead, press pause, and think about that. But the main ways are through solar heat gain, through air leakage and ventilation. So if you bring in fresh air and it's warm outside, that's heat gain. Internal heat is actually a big part of commercial building energy use. Anything that uses energy inside a building, people, lights, computers, equipment, you name it, all of that provides internal heat. So all of that energy that people are constantly giving off heat through metabolism, something like 200 BTUs an hour. Any electrical equipment, all the electricity that it uses is ultimately converted to heat because of the second law of thermodynamics. So that's a big part of especially commercial energy use because a lot of commercial buildings have a whole bunch of lights, a whole bunch of people, a whole bunch of computers, a whole bunch of equipment, and so forth. So all of that generates heat. And so that's an internal heat gain. And then also, again, it depends on the season and the temperature structure, but the transmission through the building envelope, right? So if it's hot outside and cooler inside, then some heat is going to get through the walls. It's just how heat works. Okay. So how do we maintain a proper temperature? We do things like sizing our heating and cooling system. We have insulation, air sealing, shading to block sunlight or allow sunlight in, depending on what we want. But all of these are things that we will go over in this class. Heating and cooling is a really big one, but we'll also go over insulation, air sealing, and shading. Okay, so that's our heat gains. So I want you to think about how heat can be lost in a building. Go ahead and press pause and think about that. And really, it's the similar, but sort of opposite, right? So just like we can have warm air leaking in the summer, we can have warm air leaking out in the winter, right? And then through ventilation, imagine it's really cold outside and you're bringing in fresh air. That's cold air, right? And so that's actually when you bring in that cold air, that an equivalent amount of warm air goes out of the building, which we'll talk about later. So that can result in heat loss. But also through the surfaces, just like here, we have, through the envelope, same thing. If it's warmer inside than it is outside, that heat's going to move through the walls and the ceiling and so forth. Okay, so it's sort of the flip side of the gains coin. And how do we maintain? Basically the same thing. Heating and cooling system. We can utilize internal, that is internal loads. We can utilize solar heat gain to warm up a building passively, which we'll talk about. Insulation, air sealing, all these things we will discuss. And the big ones that we'll really look at, especially this week, are air leakage and ventilation, which we combat with air sealing, and then the transmission through the envelope, which is just heat traveling through a surface, which is something that you can only slow down, you can't entirely prevent. Okay, so that's what we'll focus on more this week. But we'll focus on HVAC and other things more in future lessons. So just to give you a visualization of these heat gains and losses, so this is an example of, obviously this is just a mock-up. Here's a wall with a window in the middle, and you can see it's summertime, so it's 90 degrees outside, 70 degrees inside. Pretty normal temperature structure up here in the Northeast. So let's think about all the heat gains and losses, right? So you can have heat gain through the envelope. You can have solar energy coming in through the window, right? So these are all internal gains. And then we have all these possible internal loads inside, right? Like equipment and lights and all that. We have people that are emitting heat. We could have pets inside. We could have plants inside. We could be cooking. There could be showering. So all of these are different internal loads. All that's adding heat inside, right? We're inside the building here. And then we have heat coming through the envelope, just because that's how heat works. It goes from the hotter areas to the colder areas. And then solar energy coming in through the windows. And then we can have this sort of exchange where we have some warm air coming in through ventilation or leakage, or cold air going out through leakage, warm air coming in. So just remember, anytime air goes out, the same amount comes back in. And so if it's warmer outside, that means you're going to gain heat in the building. Okay, so there's your summer, and it's not meant to be comprehensive, but just to give you a visualization. And then if we look at the winter, so again, we're maintaining about 70 degrees inside, which is pretty normal, and let's say it's pretty cold outside, about 40 degrees. And if you think about all the heat gains and losses here, we're going to have, again, hopefully we can capture some solar energy coming through the window. Now we have these internal loads which actually act in our favor. It's like free heating. Well, kind of free. Some of it's free anyway. But anyway, that heats the building, which minimizes our HVAC use. We're going to have, in the summer we had heat gain through the envelope, and here we had heat loss through the envelope. Okay, so heat always goes from warmer to colder. Always goes from warmer to colder. And then again, it's sort of the opposite with the air leakage. Like we have this warm air that's leaking out, and subsequently cold air leaking in, or we bring in ventilation, which is cold air, and that forces warm air out. Either way, that is heat gains and losses. Okay, so hopefully that helps you visualize some of the heat gains and losses. Okay, and so in that discussion, again, we went over what the basics of building science, which is just how a building operates, and then we looked at some of the factors that impact the indoor temperature of a home.